Okay, so we're going to do a couple more examples of translating exponential functions. So we're going to start with this one, graph y equals 9 times 3 to the power of x plus 1. So the first step is to identify the parent function, or the part of the function that is going to be used to make a table, and that would be this portion of the function. So we have an a value, a b value, and then the x. So that's the parent function. Okay, so that's what we're going to actually make our table for. And then the second step that we'll do in just a moment is to identify the translation, which is this part. Translation is a positive h. If you remember, if it's a positive h, that means the value of h is actually negative. So that means that we're going to move to the left 1. Okay, so let's pick some points here. And again, the points that you pick are going to be points that you can use and you can graph. Okay, so they don't want to be too big because otherwise they would go off the graph. Okay, so let's use, let's use some negatives here. Let's start with -1. So 9 times 3 to the power of x. Oops, sorry, x is going to be replaced with a -1. Okay, that's going to be the same thing as 9 times 3 to the negative first power is 1/3, because negative exponents flip to the denominator to become happy. So that's going to be 9, if I multiply this out, 9 over 1 times 1/3 is 9 divided by 3, so that's just 3. Alright, so let's do this again with, let's do a 0. 9 times 3 to the 0 power. That's the same thing as just 9 times 1, because anything to the 0 power is 1. So that's just 9. Let's use a -2. I should have used that one second, but that's okay. This is the same thing as 9 times 1/9, because 3 squared is 9, and it's negative, so it moves the denominator. So when I multiply these, 9 divided by 9 is just 1. And then we'll use a positive 1. 9 times 3 to the power of 1, that's just 9 times 3, so that's 27, which might be too big for us to put on this graph unless we decided to number them differently, which we could do. We could choose to number them differently. We could choose to number by 2s or 3s, and that would get us two different values at that point. So but I'll go ahead and just graph as if they were regular numbers and not necessarily need this point here, unless I feel like we don't have quite enough to draw, and then I'll go ahead and do that one. But I'll do the first three first. So remember, when I point to them on the graph, I'm then going to shift them 1 point to the left. So -1, 3, -1, 3 would be here. I'm going to shift it 1 to the left. 0, 9 would be here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to shift it 1 to the left. -2, 1 would be here. I'm going to shift it 1 to the left. And I'm not really seeing another value, but you could probably figure this out, that this curve is starting to kind of go like this, right? You can kind of see, just based upon what it looks like, that that's the way it's kind of shifting. If you wanted to, you could try to find that point that you would be able to identify and figure out it's obviously getting smaller. This point here was originally the point -2, 1, so that means that if I plugged in a -3, oops, you would get 9 over 1 times 1/27. That would be 1/3, because 9 over 27 is 1/3. So now you could see we'd have -3, 1/3, and shift it 1 point to the left. So you can see the curve is kind of going this way. So that helps us a little bit, just know where the curve always begins to take shape whenever you start getting into fractions. Sorry, my curve's not looking so hot. But it's going to look something about like that. Okay? And that just gives you a good indication of what those are going to look like when you shift them. Okay? Alright, so let's do one more example. And this one has a fraction in it, which makes it kind of a pain to graph a little bit, or actually more of a pain to be able to figure out what the values in the table are going to be. But the parent function is this much, and then we have two translations on this one. An h that is a minus h, and a k that is a minus k. Okay, so we'll come back to that in a minute and talk about what those translations are going to look like. But let's go ahead and graph, or at least plot some points here that are going to be for the parent function, which is this. Okay, and this is going to be a little tricky because we already have a fraction as one of our values in the function, and then I'm going to have to raise it to a power of x, which could create more fractions, but let's just kind of work through this as we go. So negative 1, 6 times 1/2 to the negative 1 power. Well, what that means is this negative is going to attach to both of these numbers. If it attaches to this, it's going to become negative 1. If it attaches to this, it's going to become negative 1. Both of these numbers are now going to be negative exponents, so they would have to flip. So essentially, this whole fraction is going to flip to 2 over 1, okay? Which is just going to give you 12. If I do it again, this time to the negative 2nd power, well, that's still going to give you 1 to the negative 2nd power and 2 to the negative 2nd power, which 2 squared is 4. But that just means that these are now going to have to be flipped. So it's going to be 4 over 1. This would give you 1/4 if it was, but it would be 1 to the negative 2nd power, which would just be 1. 2 to the negative 2nd power, which would give you a 4, but they have to switch because of the negative. So that's going to give you negative, or give you 24, okay? Which might be too big for us to plot, but that's okay. Okay, and then let's do some positives. Let's do 0. That's always a nice one, because anything to the 0 power is just 1. So that's going to be 6 times 1, which is 6. Let's do the first power. If I do it to the first power, nothing really changes. This is just like 6 times 1/2. Well, 6 times 1/2 is the same thing as 6 over 2, which is just 3. And we'll do one more. We'll do to the 2nd power. That's just going to square both of these. So it's going to be like 6 times 1/4. Now that's going to give you a fraction that reduces. This fraction reduces to 1.5 or 1.5. So that one's where we're going to start to see a shift, or the curve is going to start looking like that. Okay, so let's plot some of these points, and we can kind of go from there. We don't have to graph the one that has a 24, unless of course we want to relabel that the y-axis by 2's. But we'll go ahead and graph the other. So -1, oh, I'm sorry, you have to come back to the translation. So the translation is that these are all going to translate in a certain direction. So a negative k actually means a positive, okay? So this is going to go up, sorry. A negative 3 is going to actually be the same thing as going to the right 3. And a -2 is going to be going down 2. So every point that we see here, we're going to put our cursor, and we're going to go to the right 3 and down 2. So -112, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 would be here. I'm going to go to the right 3, 1, 2, 3, and down 2, 1, 2. -224, I'm not going to worry about for right now because it goes off the graph. But 0, 6, 1, 2, 3, 4, 5, 6 would be here. I'm going to go to the right 3, 1, 2, 3, and down 2, 1, 2. And I'm going to do 1, 3. 1, 3 would normally be here. I'm sorry, here, 1, 3. I'm going to go to the right 3, 1, 2, 3, and down 2, 1, 2. And then 2 and 1/2. 2 is here. 1 1/2 would be about right there. So I'd go to the right 3, 1, 2, 3, and down 2, 1, 2. So you can see that's where it's starting to curve. If I wanted to see how much further it would curve, I could extend this and make it into a 3. 6 times 1/2 to the power of 3 is the same thing as 6 times 1/8. So if you reduce both of those, that's going to give you a teeny tiny fraction. That's going to give me 3/4, or that's the same thing as 0.75. So I could go ahead and plot that. 3 and 0.75, that's not quite to 1, but a little bit before it, or 1/4, 3/4 as would be kind of close. And then I go to the right 3, 1, 2, 3, and down 2, 1, 2. So now you can kind of see the curve is becoming a little fuller the smaller I get in my y values. But you can kind of see what this is going to do. This is going to kind of curve up like that. And you can kind of get a feel for how that looks when you're looking at those. So that gives you some indication of plotting points using translations of parent functions for exponential functions.